40, right? And so if I end up getting a score of maybe 44 for the group, right? And then I calculate it into a z-score. So my z-score would be 44 minus 40 over the normal, or the new standard deviation of what? Of, let's see, this one is 5. So I get 4/5, right? Okay. Now, if my group is bigger, like 100, right? Let's do the same thing. I get a z-score of, same thing, same score, 44 minus 40 over 1. Okay, so I get an answer of 4. Okay, this is a z-score of 4. This is only a z-score of 4/5. On which one of these two problems, no matter what the score, right? On which one of these two problems are you likely to land in the critical region? If z equals 4. But you notice it's the exact same score, right? Both of the scores were 44, yet when the group was big, it was very easy to land in the critical region, and yet when the group was small, it was much harder to land in the critical region, right? So in other words, you really want to prove something, you grab a bigger sample size, right? And it's much easier to land. This is kind of a problem though, because really there should be a better system than, oh, same exact score doesn't even land me close to the critical region. All of a sudden, increase the sample size, same exact score lands me way out in the critical region. So again, at some point somebody said, well, that's kind of a problem. And they said, okay, well, yes, the treatment's going to work in this one, right? Where this one, you might go, well, it works a little, but not really, right? And so they started saying, well, how can we take that out of it? And how can we actually say the treatment, not the idea of just the treatment has effect or it doesn't have effect. If it does have effect, like how much effect does it have? That would be important, right? Like how much effect does it really have if it has effect? And so they came up with something called Cohens difference. And what the difference actually does is it takes out one idea. Well, what created these different types of z-scores, right? It was created because when you come back to this actual standard error, it was created because the difference in the sample size created a difference in the z-scores, right? Because again, the sample size gave it a different standard error, which gave it a different z-score, right? So how do you know how much effect it has? Well, this is how you do it. You go back and you compare it to the original score, essentially. In other words, you take the group idea out of it and you go, all right, how can I come back to the very original problem, where in the original problem, I think I said my standard deviation was 10, right? How do you take your score and you come back to the original problem and you have this formula, and I'll put that in a second, that says the treatment had a little effect or it had a lot of effect, right? A little effect or a lot of effect. So let me throw that up there and I'll throw the formula and then I'll show you the idea behind it.